while we're getting set up, can you hear me if I talk into this one for now? So one of the most valuable things at uni is the people you get to know, right? And the friends you make here could be your friends for life. I've got friends from uni who I'm still really close with. But the problem is it's really awkward to talk to strangers. And so you have this thing in the first week of uni, it's like a free pass to talk to other people without it being weird. So while I'm getting set up, talk to the person next to you, or if you know them, then the person on the other side or something. Say hi, introduce yourself, and find out why did they decide to study computing. So who met somebody new? Couple of people? The person you met, what was their name?
Eric.
Cool, and why is he studying computing?
Sorry?
Why is he studying computing?
Why? But he's doing it, yeah, it's a consultancy thing.
Cool. Did anybody meet anybody interesting? Very subjective question. Well, I'm sure you're all interesting people in some way or another. So welcome to the second lecture of COMP1511 18s1. People up the back, can you hear me okay? Yeah, that's what I want to hear. So once again, I am Andrew Bennett. We're going to be looking pretty similar to last time, more stuff on printing things out, some cool things called variables, a cool thing called scanf. Should be good. So got that one out of the way. Good work. Some admin-y stuff. Like I said last time, tutes and labs start in week 1. Hopefully you've been to them. How many of you have had your tute or lab so far? Keep your hand up if your tutor is nice. I saw more hands go up and no hands go down, so it's very good to see. The tutors are hopefully all very nice people, so that's good. The lecture recordings are up on WebCMS, so the course website. Mine are there already. The other ones may or may not be. We'll get to that soon. And make sure you've got home computing set up. So how many of you have managed to go from your laptop or from your home computer, like your home desktop, how many of you have managed to connect to CSE and VLab or something SSH and written some programs or something? Cool. So people without your hands up, try and do that by the end of this week. The sooner you can get that working, the better. So I talked about this yesterday, but I'll talk about it again. If you want to get help, if you have questions, if you have questions about things, the number one place to do it, the best thing to do is to post in the course forum. So when you post in the forum, any of the tutors, any of the lecturers, and even fellow students can answer them for you. So rather than everybody asking me the same question every time, I can just say, post in the forum, I answer it once. Then that's all good. You can talk to me after the lecture, so I normally stick around for a little bit. You can talk to your tutor. Tutors are all lovely people. If you have problems with like lab exercises or assignments, or you want some help, like one-on-one help, we have things called help labs, where there are other tutors will be sitting in a lab, but rather than like running the tute lab, they'll just be there to help you with things. The times for those are on the course website. If you have admin questions, not things related to content, so not like I'm confused about variables, but things related to enrollment, I guess. Email the class account. If for some reason you need to talk to me directly, you can't see it because of the little thing down the bottom. It's just getting worse when I zoom in. So my email is andrew.bennett@unsw.edu.au, and these slides will be up on the website, so you can see those now. So a brief review of what we did last time. How many of you weren't here last time or weren't at any lecture last time, and this is your first 1511 lecture? One person, 2 people will admit it. So you missed a fantastic lecture. I'm sorry, you should go watch the videos. But we covered sort of a brief introduction overview to computing. And so this is an example of a C program. By the way, can you see those okay? I'll see, I'll turn those top lights off. It says they're off already. That one? Is that easier to see? Cool. And also, apparently the air conditioning is broken, but I'm going to push the air condition button anyway, just in case. Cool. So we looked at, this is the most basic C program you can get, pretty much. We start with a comment up the top saying what the program does, saying who wrote it, the date they wrote it. We have this hash include stdio, which we'll talk about later what that means, int main, which is the main thing that happens when we run our program, and inside that we said printf hello world, which will print out hello world. And then we did some Unix navigation. I'll probably just leave this in the slides and you can review it in your own time. But in case you've forgotten, and we'll be doing that more later on. So writing a program, remember we use gedit, compiled with DCC. So in terms of writing programs, it's a construction, like it's a problem-solving exercise. It's more than just sort of going down and straight away typing out code. So whenever you're writing a program, or whenever you're trying to do something, the first thing to do is to think about the problem. So what are you actually trying to do? And then write down what your solution is. So not in terms of like C code straight away, but sort of I'm going to do this to solve it. Break those steps into smaller steps. Convert those into C language. Use the editor, for example, gedit, to make a file that has the code in it. Use the compiler to check the syntax of the program, so to check that the things you've typed in the program obey by the rules of valid C code. And then test it on a range of data. And we'll be looking at more of this over the course and even over today. And compiling, remember, we write our C code for humans to read, and then the compiler turns it into code for the computer to read. So we write our C programs. They must be translated into what's called machine code. If you remember the crazy stuff at the end of the lecture on the screen, that was all made no sense and ran really fast. That's the machine code. That's what the computer understands. And so that's called compilation or compiling, done by a compiler. And we use one called DCC for this course. If you're working on your own computer and not on VLab or SSH, so like on your own computer, your own terminal, Linux or something, you probably won't have DCC. You'll have one called GCC instead. They're somewhat similar. And I drew a diagram last time, and it was kind of a dodgy diagram, and I lost a piece of paper, so I redrew it. And that's on the website as well. So there's sort of the 3 steps. We write the code, so hello.c. We compile the code with DCC, and we run the code. Cool. Are there any questions so far? Yes?
Do you suggest that we follow along with the code?
So do I suggest that you follow along with my code, get the words around the right way? As in type it out yourself, do you mean? Or if you have a laptop and you want to do that, you are very welcome to type out the stuff I'm typing. I can't say I've ever been a first-year student sitting in a lecture theatre watching a lecturer, so I can't say for me whether it would work, but if for you that's helpful, then by all means do it. And a lot of getting used to programming at the start is just practicing typing it out and going through writing all the right things. And in a week or two's time, you'll have it all memorized, like you have the comment, you have the main function, all that sort of thing. But for now, practicing writing it out can be really useful. Cool. Are there any more questions? And I'll grab my notes. My computer's upset. So one thing you'll find with Linux, we have a lot of power, we can do a lot of great things. We can also cause really serious problems for ourselves. My computer's just frozen up for some reason. I'll just give up on that. Cool, okay. Excellent. Were there any more questions? Okay, I will ask you again shortly if you have more questions. So we looked at PrintF before, and PrintF can do lots of cool things. We just looked at printing out like hello world, for example, and then in your labs, you'll look at printing out different things and maybe printing out multiple lines. And again, print means like displaying on the terminal. And so we just printed out the words hello world. Cool, a little bit boring maybe. Can we print more than just words? Yes, we can, which is pretty cool. The F in PrintF stands for formatted. We'll be talking more about what that means later on, but it means, yeah, we can do things. Let's try it out. So I'm going to open VLab. I don't know if you've been reading the course forum. Someone asked, like, should they use VLab? And someone said you can use SSH with exporting. If you know what that means, that's fine. And I was like, nah, back in my day, we had to do that to mark things, and it's so bad. VLab is so much better. VLab is fantastic. I highly recommend you use it. Okay. Right, and so you will push that button to get a terminal, but that has the small words, so I will run my bigger worded terminal. Cool. So remember, ls will show the files that we have. By the way, I mentioned I was going to make a gedit setup program last time. I did that. So if you type 1511 setup-gedit and push enter, it'll configure your gedit indentation and things like that for you. So that's all set up. That's all good. But I've got my folders. ls shows me the files. Can cd into cs1511. Save the things again. Go into lecture 1. But I'll make a folder or make directory called lecture 2. Cool. And so empty directory. I'll make a new file. I'll call it, I don't know, hello again .c. If I just push enter now, what's going to happen? What's the problem that I'm going to have? I heard a lot of people say the same thing in many different words, which is hard to listen to all at once. But yeah, so what you've all said is correct. I won't be able to use the terminal again. Gedit will be running in this terminal. I can't type ls or anything like that. How do I get around that? What do I do? Yes, ampersand. Cool. So I've got a file called helloagain.c. What do I have first in my program? What do I start out with? Say a little bit louder and more confidently. Yes, comments, names. So this is going to print out hello world again. Andrew Bennett. 28th. Cool. What do I need next? Yes, hash includes did.io. By the way, a thing the last couple of years has started happening, people will call this a hashtag. It's called a hash. If you call it a hashtag, your tutors will cry. So if you want to impress them, it's also called an octothorpe. The formal name for it, octothorpe. So if you want to freak out your tutors, you can say octothorpe include. But call it a hash. So hash include stdio.h. Cool. What's next? Yes, int prompt, int main, void, perfect. And then I do the closing one now so that I don't forget it. You can do that if you want or not do that if you want, but I find it better. I clearly didn't configure my gedit right. What? Okay, I'm confused. Okay, pretend that worked. So what do I want to have now? Is there a rule about what goes next in my program? No, because it's whatever I wanted to do. So this is, yeah, did someone say something?
You have to hit the main function now?
Yes, so I need to write things in the main function now. Cool, I can do whatever I want in the main function and it will run. So I will do a printf. What do I need now? Quotes, cool. What happens if I don't have the quotes and I just said printf hello like this? Yeah, it's not right. An easy way to tell it's not right is that it's not pink. Now it's pink, we know it's right. And if we, again, didn't have the closing quote, the whole thing's pink, so we know it's broken. Cool. Hello world. And what do I want at the end of my printf here? Do you remember? Yes, backslash n or a new line. Cool. Save that. And finally, at the very end, return 0. Perfect. And so over in this one, if I do this, it's not going to do what I want, is it? No. I'll just sort of drag that. Drag that. Maybe. it slightly better. Okay. So what do I do now to make it go from the C code to a program that the computer can run? DCC, yep. -O, yep. Some name. Program name. Cool, and then hello again.c. So I can say, I'll make this a bit wider so it fits in one thing. I can call my program whatever I want. So I can call it program name, I can call it hello again. You'd probably call it hello again because the source is hello again.c. It's like a convention that makes sense, but you can call it whatever you want. Cool, and how do I run my program? // cool. So it's beeping at me because I can't do this. I've tried to type H and then hit tab so that it'll complete it for me, but it doesn't start with H, it starts with P. Program name, prints out hello world. Cool. Does that all make sense? Does that seem familiar from last time? All good? Cool. So let's be slightly more interesting. Let's print out. Someone tell me a number. 35, did someone say? 35 and 17. That's a really hard one to do in my head. I'll just make it be 3 plus 17 equals 20. Is that right? I can do computers, but I can't do like basic math. So I compile that again, run that again. 3 plus 17 equals 20. So I've printed out numbers. Cool, I've just typed the numbers in, printed them out. Kind of boring. What if it was a really hard one, like 35 plus 17, and I didn't know how to do that in my head? Wouldn't it be nice if the computer could work it out for me? What a surprise it can. So I can tell it, actually print out the thing that is 35 plus 17. And so I'm telling it, here are two numbers, add them together, and then print out that number. And in order for it to do that, I have to tell it, hey, in this spot here, print out that number. So I have this thing, %d, percent is the one, shift 5, d for like decimal number. So I can say 35 plus 17 equals %d, some decimal number, and then a comma, and then this is the number to print, so 35 plus 17. Cool. And now if we run this, 35 plus 17 is 52. Pretty good. Cool. Computer can do basic math, yeah? You don't get the %d thing. That is completely fine. I said the words very quickly and not in much detail. So when we want to print out a number, like I want to say 35 plus 17 equals the answer to 35 plus 17. I can tell printf, like, hey, this is what you should print out. Add these numbers and print that out. But I need to tell it where to print it out. So whereabouts in this line of this thing plus this thing to print it out. And so this %d here is its way of saying this is the spot to put the number in. Does that make sense? So what if I wanted to add any two numbers together? Do you reckon I could change this to %d and this to %d? Yeah, maybe? No? I'll give it a shot. So I've got %d, a number of some kind, plus %d, another number, equals %d, new line. What do you think is going to happen? Compile error? It might work and break. It might not work. Let's see. I got a warning that's sort of like an error. But what have I done wrong here? People who noticed there was something wrong, what's the problem that I have? Yeah?
You're not giving it enough data.
Yep.
Asking for 3 digits, you only give 1.
Yep, exactly. It's asking for 3 things, and I've only told it one thing. I've told it this thing here. So I'll tell it, hey, 35, 17, and then 35 plus 17. So you'll notice I've put commas between each of the things. So like this is the first thing, this is the second thing, this is the third thing. Cool, and so now if I compile this, no errors. Now if I run this, 35 plus 17 is 52. Cool, making sense so far. I can put %d in place of the number before, put the number here, and it'll print it out. So what if I wanted to add some other numbers? Tell me some other numbers to add. 2? I'll do 2 plus 17. So I've changed the 2 here, right? I wanted to do 2 plus 17. Save, compile, run my program. So 2 plus 17 is 52. No, it's not. It's 19. So what's happened here, right? I've decided I want to do 2 plus 17 rather than 35 plus 17, but I've only changed this 2 and not this one to a 2. So like I have to change it in 2 places and I only changed it in 1 place, so it didn't work. Wouldn't it be nice if I could like tell it, hey, this is the number that I want to add up, and I might tell you later on what it is? So I can actually do that. I can say, hey, give me a variable or like a box I can put a thing in called first, and of type int, so it'll store a number. And so I might say equals 2. All good so far? And then I can say like int second equals 17. And so now I've said, make me a box to put a thing in, call it first. Make me another one, call it second. Put 2 in this one, put 17 in this one. And so now, what do I have instead of this 2, 17, 35 plus 17? What do I have instead of the 2? First, cool. What do I have instead of the 17? Cool. And what do I have here? First plus second. Sounds good. If I make this a little bit smaller, is it going to be too small? Size 17, size 16 now. People up the back, is that a good size still? Cool. I want to drag it like a little bit wider, but the draggy bit's covered by that. There we go. Cool. So some number plus some number equals some number. The first one being first, second is first plus second. Let's compile this. Let's run this. 2 plus 17 is 19. So that's good. And now if I wanted to add different numbers, like I could make this be 20 plus 17. I've got to change it in just this one spot. Compile again, run it again. 20 plus 17 is 37. So does this make sense so far? Is anybody confused? Let me try again. Is anybody not confused? People who didn't raise your hand, are you confused and like embarrassed about it, or are you just not paying attention? Does anybody want me to explain more about what variables are? One person, yeah, lots of people raise their hands. So I have this thing that I started doing last semester where I can draw stuff on my tablet and have it show up on one of the screens. So this is like handy for drawing diagrams and stuff. And I'll start a screen recording so I can see as well. Cool. So in terms of what I've done, I've said, give me a thing called first. Is that readable? Readable-ish? Cool. And so that's like a box here, right? And I've said, make me a thing called second. I've made them be ints. So this is like saying these boxes can hold numbers, specifically integer numbers. And so when I say int first equals 20, what I'm saying is, in this box here, put the number 20. And then similarly, int second equals 17, put 17 in this box. All good so far? Cool. So what if I wanted to change these once I've made them? Like I want to print out this thing here, 20 plus 17, but then I want to change first to be something else. So if I say first equals 200, what do you think this is going to do? This line of code here. Error? Could be. Probably won't be. Yeah? Yeah, change the number to 200. I hope that's what it will do. I think that's what it will do. Let's give it a shot. Cool, so we can see it's gone 20 plus 17 is 37. That was this line here. And then 200 plus 17 is 217. So what's happened in my code, I've had this line, make me a box first, make me a box second, print them out, and then change the number in that box to be 200. Like that. And so then the second time I print it out, because first now has the number 200 in it, it's going to print out the 200 instead. Yes? Cool, very good question. I'll answer that in one moment. So the question was, when I did this line here, why did I not have the int or the word int in front? And the reason for this, there are sort of 3 different things we do with variables. Maybe I'll go to my slides because I have this written down. Cool. So the 3 things we do with variables. First of all, we have to declare it. So we have to sort of make this box to put it in. So, for example, we say int num or int first. And so that means make me a box called num that will store an integer. The next thing we have to do is initialize it. So before we use it, we've got to give it a value. So for example, saying num equals 5 means we've put the value 5 in this box. And then the final thing we can do is assign a value, so like update the value inside it. So num equals 27 here would change this 5 to a 27. Does that make sense? So when we declare a variable, when we make a new box, we've got to say, hey, this box will hold integers, because otherwise the computer doesn't know what's going to go in there. You might find if you've written Python, how many of you have written Python code before? So you'll find in languages like Python, you don't have to do this. You just say, hey, num equals something. That's because Python sort of makes up the types on its own inside. It kind of goes, oh, this is an int, oh, it's actually not an int, blah, blah, blah. But in C, we explicitly say, hey, give me a box that'll hold an int and call it num. Does that answer your question? Cool. Are there any other questions? Yes. Is it limited to numbers? What a good question. What do you think? Do you think in our programming language we can only ever store numbers? It'd be pretty useful if we could store other things, wouldn't it? We'll look at that next time. The answer is yes, we can. At the moment, we're looking at numbers because they're simple and straightforward, and then after that, we'll look at some other cool things. Yes, very back corner. Very good question. Do we have to put it in 2 separate lines? No, we don't. We can do declaring and initializing in the same go. So int num equals 5, we'll say make me a box called num and then put 5 in it. Good question. So looking back at this one, I said we have to initialize it before we use it, right? So if I go back to my VLab, F8 full screen. So what do you think would happen if I just said like int first doesn't equal 20, and then int second equals 17, and then printed it out like this? So some people are saying error. What else might happen? Might be made 0. What else might happen? A warning? Hopefully a warning. Any other ideas? What was in memory before? Hold that thought. Yeah, so it might have an error, it might do something, it might be 0, it might be something else. Let's run it and see. On that note, let's pretend you didn't see that yet. On that note, if you ever don't know something or have a question about something, there are several different ways you can get help. One of them is ask somebody. So ask your tutor, ask your lab pair, ask on the forum, ask me. Another one is to Google it. So, Google like this error message here, and then Google will hopefully tell me this means this thing's going on. So ask someone, Google it. But then what's the third thing that you can do if you want to find the answer to something? Any ideas? Someone said something? Yeah, see yourself. Try it and see is what I say. So it is very, 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 very unlikely that something you do in this course will have really bad consequences if you do it wrong. Like if you're using the C language and you're doing stuff in this course, it's very, very, very unlikely that your computer will like blow up or you'll destroy the universe. Like the worst thing that can happen is that your program will crash. Disclaimer, if you do things that we don't teach in this course, you could, again, like you wouldn't break your computer, but you could do more weird things. But I give you free rein, experiment as much as you like with C. Nothing super bad will go wrong. Things will be okay. So definitely experiment, see what's going to happen. So this error I got here when I tried to compile it, saying error redefinition of first. So it's saying, this is saying line 16, I said in first is 200, then on line 11, I previously said in first. Any ideas what this means? You know how I said when we say like int first means make me a box to hold an int and call it first, right? What happens if we say int first again later on? Yeah, it's like saying, okay, make me another box, also called first. But then which one is the real first? If we talk about the variable called first, like is it that one? Is it that one? Who knows? And so to avoid the confusion, this is like one of the rules in the C language, is you can only have one thing with a certain name. So when we say int first up here, we can never make another variable called first in this function, in the main function. So how do I fix that? What do I change about this line? Yeah, I can remove the int, because this line is just trying to set the value of first, like update the value. So I don't have to make a new box, I just change the value that's already in the box. Let's try this again. So if you remember, we don't have anything int first equals, like doesn't equal anything, we just declared it. Saying it's used uninitialized, we need to initialize it first, so initialize means give it a value. Let's just be like, nah, I don't want to do that, and run program name instead. So, yep, negative 4,400,000 plus 17 equals this other number. Who knows? But I will say int first equals 0 for now. 2 is a nice number. Recompile, doesn't complain, rerun. I've given it a value, I've initialized it. Instead of just declaring it, it prints out the world is happy. Yes? Very good question. Do we have to compile our code every time we make a change? Yes, we do. You'll find in languages like Python, you don't have to compile at all, and so you never have to compile. But in C, remember we have that 3-step thing. We write our code, we compile our code, and we run our code. So whenever we make changes to our C file, they're only like within the code, they're only within the source code that we're writing, they don't go to the actual program unless we run the compiler DCC. Cool. Any other questions? Yes?
How do you print special characters using PrintF?
How do you print special characters using PrintF? What is a special character?
Backslash or %, or hash?
Very good question. Why would that be hard? Like, why is it hard to print out backslash or %? Yeah, because it thinks it's part of something special, right? So, for example, if I said like printf %, like maybe I wanted to say 100%, for example. I'll put a new line there. I will comment these lines out. Comments mean the computer won't read your code, which is convenient when we want to not have it look at our code. So I want to print out 100%. Remember, percent is special because like we do %d to print out a number. What's it going to do here? Might break, might have an error, might work, might do something weird. Computing's weird like that. It says warning, invalid conversion specifier. Who knows what that means? Let's run it and see. That's an interesting thing that it's printed out. That's not in my code anywhere. So it's printed out equals equals 30836 warning, unexpected format specified, blah, 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 percent. And then 100%. So it could have crashed, it could have not worked. In this case, it's complained at us. But like we said, percent is a special character. We want to do like percent for percent %d. It turns out the way to do a percent that's just a percent, so rather than like percent %d for a number, we just do percent %. And then that means print me out a percent. Try that again. Cool, 100%, very happy. Your other question was like a backslash. How do we print out a backslash if, you know, printing out PrintF. This is a backslash, and then a backslash, and then a new line at the end. So again, is this going to work? No? Let's try it and see. Yep. So was your question, is gedit limited in the mathematical functions it can perform? So I'm not sure what you mean. Do you mean the C programming language that I type into? Yeah. Yes, it is. You can't do, I can't think of a fancy mathematical thing. Like, you can do things like divide, add, subtract, that sort of thing super easily. You can call code other people have written to do things like, you know, cos and san and square roots. If someone else hasn't made code to do something really fancy and mathematical, then you can't do that. Does that answer your question? Cool. So it says unknown escape sequence backslash. Looks like you have a space immediately after a backslash, but shouldn't. Gosh, thanks, compiler. So if I run this again, there's no backslash, it's just printed nothing. So what do you think I need to do to get it to print a backslash by itself? Escape the backslash? What do you mean? Put a backslash in front of my backslash. Yeah, and so we can see it's now turned this purple color, the new line, so it's saying, hey, this is now a special character that I know about. And if we run it again, this is a backslash and a backslash. So yes, if you want to print a percent, percent, percent. If you want to print a backslash, backslash, backslash. Yes.
What if you try to
Print a double front slash, so like that. So because front slash is not special, it'll just print out 2 front slashes. Cool. Did you say what is an escape sequence? Did it say that up there? Yes, it did. So an escape sequence is a backslash followed by something else. That's the technical name for it. Yes? Sorry, can you say that louder?
Why doesn't it do like from 12 to 20 anymore? Like when you run it, why does it really do 9 lines?
Cool, so why does it not run these lines? So I've put the comment symbol in front of this. So like up here we have a comment saying, you know, this is what my code does. Comments are things that the compiler ignores when it makes the program for the computer to run. So normally you use comments to say what's going on in your code, but if you're kind of lazy and you want to delete some code or test something by removing code, you can just comment out the code. Cool. Any other questions? Okay. What were we doing before we had those questions? I guess I'll jump to the slides. So this is what we were looking at before. Sum 2 numbers and print them out. So we said the sum of 3 and 5 is %d, or we said like 3 plus 5 equals %d. And then we can do the 3 plus 5 there. And it's boring if you can't do it dynamically, like if we always have to have the same numbers we add, sort of sucks. So we have these things called variables, which are like boxes. So like I've got here, each one has a data type. So that's what can go inside the box, what type of thing it will hold. So we've seen ints so far. We'll also see floats, or maybe they'll be called doubles, which store things called floating point numbers, which are non-whole numbers. So like 3.14159 ... 2.71828 ... Like these are not whole numbers. We couldn't store these inside an integer. And so we have a different type of number called a floating point number. And like someone said before, do we have things other than numbers? We'll look at more ones in future weeks, but for now, can you think of any types that would be useful to have? I heard lots of people saying like C. Strings, I think I heard. Dates? Yeah? Characters, yep, like letters, yep. Important things? Input, yes, things we get as input, yes. Have a think about this. We'll look at more types, but even as we learn more types, think about, is there anything more that could be useful? And then maybe someday we will show you how to make your own types. It'll be very exciting. So like I said before, we declare, which is like saying, here is my box. It is called num, and it holds like an int. So this will fit one integer. We initialize num equals 5, we put the value 5 in, and we can do this in one line. And then later on we can assign a new value to it, so that's like deleting this value and writing 27. We can also do them in the same step. So when we're making names for our variables, there's a good quote. It's like there are two hard things in computing. I'm going to get this wrong, so I'm going to Google it. There we go. So there are two hard things in computing: cache and validation, you'll learn about in later courses, naming things, and off by one errors. That is a thing that you will see a lot in computing in this course. Off by one error is when you have two things, but actually you have three things. But it's, you know, a very hard thing in computing is having good variable names. Shh. So why would it be, like, why do we care about the variable names we have? Readability, what do you mean by that? Yeah, if you're working in a team or looking at your own code even, other people need to be able to read your code. That's very true. And I'll give you some words of wisdom from my own programming experience. You should write code as if you don't remember how it works, because you'll look at it again in a couple of months' time and you won't remember how it works, and you'll be like, oh my god, Andrew, why did you not explain how this works? Use better variable names. So as you're writing the code, imagine that someone else will have to read it someday, maybe even yourself. The rules for variable names, we can have letters, digits, and underscores. The first character must be a letter, so we can't have like the digit 1 as a variable name. We can have num1 as a variable name, for example. They are case sensitive, so like num with a lowercase n and a capital N are different things. And then things called keywords, which are like special words in the programming languages, you know, if, while, do, int, can't be used as identifiers, like can't be used as names. Cool, and printing variables out, we can print no variables, just like we did before. The single variable is like 1%d, so int num equals 5, num is %d, and then comma num. More than one variable, like we saw before, num1 and num2. The order of the arguments is the order that they will appear. So if we have int num1 equals 5 and num2 equals 17, and then we have them like backwards, num2 is %d, num1 is %d, because num2 has come first in this list of things in the printf, that's the one that it will do in this first spot. So it uses %d. I deleted some stuff off the slide that I actually had to put back on. Floating point numbers use %f for floating point numbers. We'll look more at those in later weeks. So someone said before, a useful type, what's the time? I think it's time for a break. Let's have a short break. Do you think it's time for a break? Yep, cool. I will have an exactly 10-minute break. Get up, go to the bathroom, stretch your legs, jump up and down, make some new friends. 4, 3, 2, 1. What? I can't hear it. There we go. The beep means be quiet. So it turns out the beep comes through that screen because it didn't beep when I had my tablet up there, but that's the one being recorded. That seemed like a mistake. Anyway, welcome back. I hope you had a nice chance to stand up and walk around again and sit down again. It's very boring to sit still for 2 hours, like you'll fall asleep. I'd fall asleep. It's a good thing I'm standing up. So, a couple of quick admin things. VLab is fantastic and you should use it. However, if you Google VLab UNSW, you should not use this one. You don't want to use the one called VLab Gateway, like the web browser one. If it's in a web browser, you shouldn't be using it. You should use this if you're in like China and you can't open a VNC client, or if you're behind like a government firewall in a high school in New South Wales, which many people are. But if you can run programs, then you should use actual VLab. So search for any VLab other than this one here. All of these ones probably work. Look at all those. This one has instructions, this one has instructions. So basically, search for VLab, do not use the web browser one, do use all the other ones. Cool. Right, and another thing, there are resources on how to do home computing stuff on the website. So under home computing, there's videos on how to do things, there's instructions for things, so make sure you get your own computer set up before the end of this week, if at all possible. Instructions here, videos here, everything is good. If you have any questions, course forum, tutor, me, classmates, anybody. Cool, so are there any questions before we get started? Not yet. I must not have confused you enough. So, someone said earlier that it'd be really nice if we could also get numbers into our program. So rather than just printing out numbers, also like take input from the user and do something with their numbers. So we have a thing called scanf. It's like PrintF, but instead of printing, it scans, which is like scanning a value in. I will just open VLab and show you. By the way, if I talk too quietly or too fast, please just like wave at me or be like, Andrew, slow down. I talk really fast, and when I get excited, I talk even faster, and I try to slow down, but if I'm talking too fast, please tell me. And if I'm talking too quietly for up the back, please tell me again. I was in a horrible lecture theatre last semester. Have any of you been to the science theatre? Oh, because you're new students. So you might go to like shows like CSE Review, which is like a comedy sketch show that CSE put on in the science theatre. It's not a good place to lecture. It's a good place to do shows. So I recommend you don't lecture there. But people couldn't hear me up the back, and it was terrible. So I'm glad you can hear me. If I'm talking too fast or too quietly, please tell me. Let's make a new file. Let's call it, I'll call it input.c. Boring. Do some scanf input stuff. So remember name, what your program does, date, 28th. So while you're just starting out, it's perfectly fine to like copy some old code and then just delete the middle of it. Hopefully soon you will know all the stuff yourself, and definitely practice typing it so that you get used to it, but it's fine if you just copy and paste for now. So here is my blank program. I'm going to make a variable called int num. So we talked briefly about good variable names. Is num a good variable name? What does it tell you? It's a number. You kind of already knew that because it's an integer, right? Like, that's not a very useful name. So I want to find out someone's favorite number and then print it out to them. So I'm going to start out by working out what our program does, and then work out how to turn that into code, and then do the code. So I'll change this again. Ask somebody's for favorite number and print it out. So I want to start out by asking for their favorite number, get the number from them, print out favorite number. So if I want to get somebody's favorite number, like let's use a person in the classroom. I want to find out this tutor called Alex's favorite number. So this is how it's going to work. I'm going to say, Alex, what's your favorite number? Alex is going to say 17, and I'm going to say, cool, Alex's favorite number is 17. Right? Like that's sort of the process that you follow with a person doing it. You ask them, they tell you, you go, cool, I know this thing now. And so that's the same steps that we'd follow in our program here to do this. I find it really helpful to write the steps out first and then write the code. Even for my own programs, like not just first year programming, but like for all of the programs I write, I do this. It's much, much simpler. So given that I want somebody's favorite number, is there a better variable name than num? Favnum? So I could write favnum. What's a favnum? Favnum? I might as well write like favorite number. It's fine to have long variable names because the thing that constrains your coding speed isn't typing. Even if you type really slowly after you've been coding for a little while, like the slowest thing is the thinking rather than the typing. You can also set up often your text editor to autocomplete variable names for you, which makes it faster as well. But I reckon it's better to have a readable name than to have a really short, easy to type name. Like you could just have F for favorite number. Cool, that's a great variable. You're going to read my code and be like, okay, what's F? So write the code for the people to see. So I want to ask for their favorite number. How am I going to ask for their favorite number? Heard someone say scanf and someone say printf. I want to ask somebody something, so I'm like saying it to them. So how do I do that? PrintF, yes. PrintF, what is your favorite number? And then the new line at the end, so that it looks good. Then I want to get the number from them. So we very briefly saw scanf. What goes in here? Who knows? Let's do the easy thing first. Let's print their favorite number. So how would I do this? Like print out your favorite number is, and then how do I print a number out? %d? Yep, because I need to tell it, like put the number in this spot here. What else do I need in here to tell it to print this number out? Yeah, the variable name, the thing for it to print out. Favorite number. Cool. So I've gone printf, what's your favorite number? Scanf, we'll do later. Printf, your favorite number is this thing here. So I will simplify this line down to be really boring and just print out the number. So I could do, like the most basic printf I could do is just print out the number and then favorite number, right, the variable name. Scanf is actually really similar. So I can basically just change my printf to a scanf. Except there's one really important thing that I need, which you might have seen on the lecture slides. Did anybody see the difference between what I have here and what scanf needs? Yeah, an ampersand, an and. And the reason for this is printf prints out a number, like it just takes the number and prints it out, like it reads what the value is and prints it out. But scanf puts things into numbers, like into a variable. That's sort of a bad way of explaining it because this does too. When you're giving your variable to scanf, in order for it to be able to put it in, you need to give it the ampersand. And then when you're telling printf to print out your variable, you just pass it in the variable without the ampersand. So basically rule of thumb, scanf, ampersand, always ampersand, otherwise things go badly. Cool, so what's your favorite number? Scan in their favorite number, print out your favorite number is this. Do you think this will work? No? Why are you so pessimistic? It's great, I've written beautiful code. The variable is uninitialized. That's a good thought. Do you think it'll still work? Yeah, so I'm sort of initializing it with the scanf. Like when I do the scanf, it's putting a value into the thing. So because I'm only printing it out after that, it's fine, like there's gonna be a variable in there, everything's great. So, whoa, for now, let's assume that scanf will initialize it for us. So I will compile and run this. Favorite number. It's still called input.c, that's a terrible name. So I'll clear this that is at the top. /favorite number to run my program, put favorite number. What is your favorite number? Anyone? 7? Your favorite number is 7. Good work. You got it right. Computer got it right. So does this make sense so far? We can get the user to type things in. Like it'll sit here waiting for me to type something in. And then when I type something in and push enter, it'll go into my program. So it's like when we run our program, it prints out this printf, all good and happy. It hits the scanf and it waits for us because it needs someone to type something to scan in, right? Then once we've typed it in and push enter, it can move on and moves to the printf. Printf, your favorite number is this number. Yes?
What does the first argument in the scanf mean?
What does this thing here mean? Yeah. So the first thing in the scanf, again, with the printf, we had to say this is a number that you're going to print out. Scanf, we have to say this is a number that you're going to scan in. So if we had %d, %d, we could have an age, sure. Favorite number and age. You are %d. So I can do this, I can have scanf %d space %d, and this will scan in number space number. What have I got wrong here though? What have I forgotten to do? I've made a variable age. Yeah, I haven't put it in here. Okay, and what have I got wrong still? I didn't even notice that one. Good work. What's the mistake I intentionally made? Ampersand, yep. Shift 7 and ampersand, whatever you want to call it. Cool. I'll compile this again. DCC. I will run my favorite number program. What is your favorite number and age? Anyone? 17 and 21. So we've typed in 17 space 21. It said your favorite number is 17 and you're 21 years old. Pretty good. Anyone else? Cool. Sorry, say that again. What happens when you... What happens if I put something that's not a number? Okay, so what if I said like my favorite number is 5 and my age is like 50? 69? That's remarkably close. There's your answer. Shall we try it again? Maybe if the favorite number is 17 and age 20. Okay. Still the same. It's a bit weird. What about if I say my favorite number is -1, 16 something, and I am 69 years old. Yeah, got it right. Go computer. Yeah, question? Say that again. In the scanf? Yep. So when we do scanf, because we're putting things into the variable, we have to put the and in front for scanf. So printf just prints it out. That's fine to just do it normally. But when we put something into it, like when we change the variable from scanf, we have to have the and in front. Does that make sense? Cool. You first. What happens if you don't put the and, did you say? I could Google it, I could tell you, or we could try it and see. That sounds more fun. Was there another question around here first? Yeah?
What happens if you put other stuff into like a string function?
Other stuff into this part here? Is that what your question was? One thing at a time to try. So we'll start out by trying not having the ands. What do you think will happen? I mean, it's saying that I'm wrong, but we'll just ignore that. Like it's a warning, who cares? Warning me that there's a bug. I don't have bugs in my code. So favorite number, 17, age 21. It's an interesting age. So, back in my day, before we had DCC, we used a compiler called GCC, and I'll just show you what it looks like with that. So I'm going to call it blah. So this is the same code compiled with GCC instead of DCC. 1721. Segmentation fault. So segmentation fault are words that you will see a lot in your life. This is, for many of you, your first segmentation fault. You'll enjoy. And in DCC, it's unfortunately called ascend deadly signal. It's not as nice. It's not as terrifying. So what this means is that we have a fault in our segmentation. Any idea what that actually means? Yeah? Yeah, so our program's doing something that it's not allowed to. It's like accessing a segment of the memory that it's not allowed to. I wonder why that's happening. That's a really good question. Why don't you go play with it and see if you can find out why this happens? The short answer is just put your ands in and then it won't crash and it's all good. The long answer is it's actually really cool what happens and you should go find out, and if not, I'll tell you in a few weeks. What was the other question, if we have other stuff inside here? So it's like in PrintF we have words and then the like %d and stuff interleaved, right? So this will print out your favorite number is %d number. If I do scanf %d, hello %d, this wants to read in a number, space hello, space another number. So if I compile it again, I run it again. So if I type just like 17, 21 we had before, like if I just type number. So the 17 worked, the 21, 69. Bad things are happening, right? It's sort of working, it's sort of not. And that's because it expects to see a number, then a space, then hello, then a space, and then a number. So if I type 17, hello, that was compiling, 17, hello, 21, it'll work. Does that make sense? So you don't really need to know this. Like, all you really need to know is that scanf %d will scan a number. But if you have other things inside this, we call this a format string, then it'll expect those things to look exactly like that when it scans them. Was there another question over there I saw? Yes?
What happens if you just type in one number and then enter? Will it go to 0 or?
What happens if I type in one number and push enter? So I typed the control D in there. Control D means end of file, technically, but it basically means I finished typing an input. So what happened here, I gave it one number, right, but it's expecting more numbers, and so because it thinks that there should be more numbers, right, there's still stuff here, it's going to wait until I give it that. But I can hit this control D end of file thing, tell it, no, actually I'm finished, and then it'll go again, you're 69 years old. Yes? Where does the 69 come from? Maybe the computer's 69 years old. Like, who knows? Very interesting question. Maybe you should find out. Was there another question? Or was that? Okay, well, are there any other questions on top of those questions? Okay, let's go back to the slides and see what I've forgotten to tell you. So like I said, scanf, we can scan numbers in, %d, ampersand num, that's a really weird ampersand. The variable is initialized, so we don't need to do this in num equals 0 to start out with, but it's good to do it just in case it doesn't get a number for some reason. And don't forget the and, the ampersand, before the variable name in the scanf. Very important. And so we can read in multiple variables, like we saw, num1, num2 equals 0. So scanf %d space %d expects to scan in number space number. Scanf %d comma space %d expects to read number comma space number. And so whatever you have in here is what it will expect to see when it's scanning things in. Cool. Any more questions about scanf or other things related to scanning or printing? Okay, well, let's learn something else that's new and really cool, and I'm going to drink some water first. What is like the one thing that, pretending you didn't see the next slide, that would be really cool to be able to do in our programs? Like right now it just goes, does this thing, does this thing, does this thing, start to end, nothing changes, always boring. What would it be cool if we could do? And not do multiple things, because like not do things repeatedly, because that's like next week. And the idea is like we want our program to not just like do this, do this, do this, do this, end, because that's boring. We want it to like do different things based on what's going on. Yeah, we want to have our code be able to make decisions, do different things in different situations. And so an example program about this, let's say we're working for, what are they called, Service New South Wales now, used to be called the RTA or something, the people who do driving tests. And let's say they want you to write a program that says whether someone can drive from their age. So they've said, hey, ask them for their age. If they're 16 or more, tell them you can drive. If they're not, then they can't drive. And then either way, say, have a nice day. So let's sort of break this down into steps. What are the steps there? The first step is like ask the user to enter their age, right? So what does that involve? Yeah, printf and scanf. Print out, enter your age, scanf their age. Then if they're at least 16 years old, or if they are at least 16 years old, then display you can drive. Then whether or not they can drive, display have a nice day. And so sort of the key things in here, like the logical structure is, if this thing is true, then do this thing. Right, and so step by step, print out how old are you, read in their age. If their age is greater than or equal to 16, print you can drive, and then print have a nice day. Let's code this up and see how it goes. I call it that's not the right editor. My brain went into autopilot. I'll show you that actually. So the editor I use is called Vim, and because I'm making a file, my brain went into like autopilot of let's make a file. I'll open like helloagain.c. You can see it's got coding and you can type stuff, but actually you've got to do other stuff before you can type stuff, and you've got to do confusing things. It's really great. If you want to try it, try it. If you don't want to do scary hard things, then don't try it. It's very powerful, but it's also very complicated, which is true of many things in computing. So I think that happened in my first lecture last semester, not my second lecture. I accidentally opened Vim. Let's do this driving thing. Copy this code. Print out whether somebody can drive. So you'll notice that it's all like not colorful and it's all black and white. Any idea why this might be? Yeah, it's not saved. It doesn't know that it's a C program. Driving1.c. Ta-da, there are colors. So what did we say our steps were from before? Rather than try and do things at once, so I'll look on here. So we want to ask their age. If they are 16 or more, print you can drive. Print have a nice day. So ask their age. We're pretty good at this one. In age, make a box to put the age in. What do I do next? Yeah, printf, what is your age? Cool. How do we get their age? Cool, scanf, %d because I want a number. and then putting it into age, ampersand. Cool, and so if they are 16 or more, print out that you can drive. So like if they are 16 or more than PrintF, you can drive. And then print, have a nice day. So this isn't going to compile. There are rules about how we do things in C, and we haven't quite followed the rules. The compiler doesn't know what if they are 16 or more means. But you can see the word if's gone red, because it knows if is like a valid thing we can talk about. The syntax for if is fairly straightforward. We have if, circle brackets around it like we have when we call printf with the functions, but circle brackets to say what the condition is, so what the thing has to be true, or thing is that has to be true. We have an open curly bracket to sort of say this is the stuff that happens if you can do this. And I indent this out across one because then it's nicer to read. Cool, and so if they are 16 or more, print you can drive. How do I know if they're 16 or more? Yeah, I've got the age variable with their input, right? So I want to say like if the age, yeah, is greater than 16. But hang on, if you're 16, you can drive as well. So yeah, greater than or equals. And you saw it was drawn like with the line underneath the equal sign and the math notation, but here we say greater than symbol, equal symbol to say greater than or equal to. Something that can be confusing is which way around they go, but you don't say equal to or greater than, you say greater than or equal to, if that helps. So if the age is greater than or equal to 16, print out you can drive, and then either way, print out have a nice day. Good spotting. That bottom print needs to be a printf. Clearly it's an intentional error I made to see if you're paying attention. Cool, so I've compiled my program, run driving on. What is your age? Someone? 21? You can drive, have a nice day. Do we know if our program works? It's printed out, you can drive. You're shaking your head, you said 12. Why do we have to test it with entering 12 as well? So you all said different things at once, but I'm guessing what you said was because we don't know if it's actually working or if it just always prints out you can drive. And so the only way I can tell if it's working is if it says no to somebody who's not 16, right? So when it prints out 12, or when you type in 12, it doesn't say you can drive and it says have a nice day. Cool. Have we established that it works yet? Yeah, we should try 16. Why should we try 16? Yeah, it's the middle. It's what we'd call like an edge case. It's where one piece of code and the other piece of code sort of meet. So 16, you can drive, have a nice day. That's good. Yes?
Instead of age, can you write %d?
What do you mean by instead of age, can you write %d?
You know how you say if age is greater than or equal to 16?
Yep.
%d is greater than or equal to 16?
So this won't work because %d is a thing inside printf. Printf format strings, we call them. So whenever you're inside a printf or a scanf, you can use the %d to mean a number. But when you're just in normal code, like you can see it hasn't changed color, you need to use the variable age, for example. Cool, good question. Any other questions? Yes? Why do we not have a semicolon after the if? That's a very good question. Let's try and see. So what do you think will happen if I have a semicolon after the if? Sorry, say that again. I heard some of those words, but not all of them.
So why don't you use the semicolon on the closing bracket of the if on line 17?
Oh, why don't I have one at the end? Ah, I see what you mean. So why don't I have one like that?
Yeah.
So remember we said like C is a language that humans write and then it follows the rules that the compiler understands to make the computer code. We need the semicolon here, for example, to say that this is a thing that's happened and it's done. So, int age, made a thing called age, type int, this is over. But with the if statement, the compiler knows that it's finished once we hit this closing circle bracket. It doesn't need a semicolon as well to tell it. Does that make sense? Good question. Any other questions? Yes. Why did we need like these ones here? So we needed to know like what happens inside this if statement, we call it. So if we didn't have them, let's pretend that we did multiple things in here. So if this was like this and we didn't have these, then it wouldn't actually do them only if this was true. There was another question around there, maybe? Yes? Sorry, I can't hear you. I really can't hear you, I'm sorry. Oh, you didn't hear what I just said? Which thing was it that I just said that you didn't hear? Right, the open and close brackets. So I'm sort of lying to you, and I'm sorry, but it's a good lie. It's a nice lie. We'll explain later why it's not entirely true. But we need these brackets so that it knows what's inside the if statement. We'd call like this here an if statement, like it's an if this is true, then do this, and like a statement. So if we had this, and again I'm lying, I'm sorry, it wouldn't know that it should do this only if this is true. So like, because we don't have the curly brackets, it doesn't know that this thing happens inside this. Like the indentation is just a thing for humans to look at. This is still valid code. The lie that I'm telling is that actually if it's just one line, the compiler will let you do it and it's fine. But if it's more than one line, you are over 16. Right, so if I have it like this without the curly brackets, because I've got more than one line, if I try and run this, this is the one attached to the if statement, and this one here will always happen no matter what. You guys might be too young. Have any of you heard of the go-to-fail bug? From a while ago, I'll type it here, go-to-fail, I think it was lowercase fail. Long story short, there was like a really serious bug in all Mac things, so like iPhone, iPad, laptop, all of the Apple operating systems. There was a very, very bad security bug, which happened because someone didn't use the curly brackets in some code they were writing. And so what happened was, the code was something like, if, I don't know, something bad has happened. Was it that way or was it the other way around? Yeah, like stop doing stuff and then go to fail. Go-tos are a thing in programming languages that you should never use. I'll leave it at that. And so then, later on they had, if something else bad has happened, then, they need to like check for this thing here and then so on. But because they didn't have the curly brackets, even though the code said this, because the curly brackets like just grabbed the one line below it, the code was effectively this. And so this important line that needed to go like inside this part here, if this was true, always happened rather than only happening when the thing is true. And this caused very bad security problems. So I don't know if I was very convincing, but basically use your curly brackets or you'll make all Apple products have security problems and Apple will be sad at you. Does that make sense? Cool.
Why do you grade analytics for 16 instead of grading 15?
Say that again, why don't I?
Why do you go grade analytics for 16 instead of grading 15?
So why do I have this rather than if age is greater than 15? Very good question. Does it make a difference? What do you think? So we'll hold on to the floats for next week, I think. But this is sort of comes down to a logical thing. So it's equivalent to say when we've got whole numbers, if age is greater than or equal to 16, or age is greater than 15, right? Because age can be like, negative whatever, 0, 1, 2, 3, 14, 15, 16, 17. So it's equivalent to say if it's greater than or equal to 16 as to say if it's greater than 15. Does that make sense? Could I put in 15.5? In this case, no, because integers are whole numbers. So they can't have decimal points. Cool. Good question. Any more questions? Yes. Sorry, can you talk a bit louder? I heard not the important part of that. People shh. Can you say that again? So you're saying when I typed out that stuff before, I typed like if blah blah and I typed else blah blah and the else changed color? Yep. So like I said before, if changes color to red because it's special and means something, else also means something special. Can you guess what it means, like in terms of the logic? Yeah, like if it doesn't meet the condition, then this will happen. So it's in English language. If your age is greater than 16, you can drive. Otherwise, you can't drive. So in C programming, we do this with like if something, the stuff that should happen, else the thing that should happen if it's not true. PrintF, you are not allowed to drive. Go back to school. Cool, and so what this will do, if the age is greater than or equal to 16, it'll print this out. If it's not greater than or equal to 16, it will print out this line instead. Does this make sense? Do you think it will work? Cool. What is your age? 15. If you're not allowed to drive, go back to school. Have a nice day. So we can see it's sort of taken, let me go to the thing. The keyboard keeps catching the thing. Cool, so let me show you. We can sort of look at it like this. We say, what is your age? And then we take the age and we say, if the age is greater than or equal, is that showing? No, I need to record. If the age is greater than or equal to 16, like if this is true, then print you can drive. And if it's not true, print go to school. So does this sort of make sense conceptually? We go through our code one thing at a time. Move that down. So our code starts out by like, scan in age. Can you read my writing? It's a bit messy. And then once we've scanned in their age, if their age is greater than or equal to 16, then we print this out, you can drive. If it's not, we print out, go to school. And then regardless of whichever one was true, we print, have a nice day. Cool, so I'll zoom out on that. Does that make sense in terms of like the structure of our program? Our previous programs are sort of like, do something, do something, do something, do something, program is over. Right, but this program here, we have this, if this is true, then do this, else do this. And we can see that here, like our program sort of forks off, splits in two. Cool, does that make sense? Is that a question? What's up? Sorry, shh. Yes. Cool, so the question was, right now we've got one condition, like we're checking if the age is greater than or equal to 16. Yeah, so what if we also want to check if they're less than or equal to 25? Well, age is less than or equal to 25. This is like how we'd say it in words, right? If the age is this and the age is this. It turns out that C programming doesn't quite understand this, so I'll compile and it'll be like, what's going on? But we can tell it and by saying the character and, so like ampersand, ampersand. And so this is the way that we can write if the age is more than 16 and it's less than 25, then do this. And less than 25. Or maybe you're too old, go to work. Cool, so I've changed this to have both of these conditions in here. If you're more than or equal to 16 and you're less than or equal to 25, print this stuff out, else print this other stuff out. So I will compile it, it's happy, I will run it. So what is your age? Anyone? 21? Cool, you can drive, you're over 16 and less than 25, have a nice day. What about if your age is like 40? You're not allowed to drive, go back to school, or maybe you're too old, go to work. Have a nice day. So does this make sense? Now, rather than just checking one thing, it's checking two things. So we saw that 21 was fine because it's more than 16 and less than 25. But 40 was not fine because it's more than 16, but it's also more than 25. And so both of these things had to be true in order for it to do the code inside here. Cool. Does that make sense? Question? Cool, so the question was, is there a way we can do or, because we can do and. Yes, we can. Or looks like this. It's called the pipe symbol. It's the one above enter on some keyboards. It also has the slash. So we can say or like this if the age is greater than or equal to 16 or it's less than or equal to 25. But let's think about the logic of this. What is this going to do now? It's always true. So why is it always true? Are there any numbers that are both not greater than 16 and not less than 25? No, because all numbers are, if a number is not more than 16, it is less than 25. So with this one here, whatever their age is, 100, you can drive. 2000, you can drive. 0, drive if you're like -5 years old. So now no matter what we type, it's always going to do this part because this combined thing is always true. Like in terms of logical, like mathematical rules, there is no number that doesn't meet those. Cool, good question. Are there any other questions? Yes?
What if it's safe if they were over 25, how do you make it just you're too old, go to work or whatever?
Is it okay if I say, I'll tell you next week? I was told that I shouldn't teach you that today and I should teach you next week. I'm sorry. Maybe you could play around yourself and see. Any other questions? Is that a question up there? Is there a limit on how many ands you can use? Well, yes and no. You need to have a file that's smaller than the largest file that will fit on your hard drive. So you can't have like a gazillion ands. You could have lots and lots of ands. So, I mean, we could pretend that these are like useful things, right, and not just the same. This is valid code. This will compile. It won't do anything differently because we're checking the same thing over and over again, right? To prove it, I'll show you. Still compiles, still works. All right, because I put it back to the and, so if you're 18. So we can have all of these. That's like, I don't know, a lot. But why is this bad? Why am I going to tell you actually you can't, don't do this? It'll work, but you shouldn't do this. Yeah? Yeah, it's not readable. Someone said readability as well. Even if I have like a normal font size, like you'd have, you guys might have like size 14, 12 even. Like even at the size you'd use when you're not showing on a projector, it still goes way off the end of the page. It will compile. The computer can understand this, but the humans can't. So it's sort of like a, technically it's fine, but in terms of like the rules of writing good code, you shouldn't do it. Good question though. Any other questions? That did not quite go to plan. Yes?
Would it be possible to make the if statement go over multiple lines if it's that long?
Can we make the if statement go over multiple lines if it's that long? Yeah, we can. I'll put it back. I'm going to do this in Vim because then I don't have to do it all by hand, so apologies. So you can see it's like wrapped around here, but I think if I do that, it'll split it onto multiple lines. So now over here, you can split it across multiple lines like this. It's a valid way of doing it. It's still not much more readable though, right? Like it's still a crazy mess. But yes, good question. Was there another question over here? Okay, any other questions in general? Is that a question or a stretch? Okay, your final chance to ask questions. Time is nearly up. Okay. If you do have any more questions, class forum, talk to me afterwards, and so on. So, before you go, what are the things I said you had to do before the end of this week? Do you remember? Go to your lab, write code in the lab, write code at home, home computing. Cool. I will see you all next week. Go to your tutes and labs.